Welcome to the afternoon session and workshop. Today, the topic is going to be navigating getUserMedia, and everybody who's built any WebRTC application knows how complicated it is. Our hosts will be Tarush, Nagpal, and Palash Golecha from Dite. And I think it's time to get started, and looking forward to learn something new. Thank you. Take it away.
We had to change the title last minute. It was too long. Yeah. But yeah, this talks about media handling in web, getUserMedia, like all the way to the playback of media. I'll just give you some context so let me talk about Dite first. We're both from Dite, and we both are working in the front-end web engineering team. And Dite's a communication API provider. We provide APIs for like RTC audio, video, LLHLS, chat. And we just have one SDK for all of this, and with a lot of focus on the developer experience. So what do I mean by that? I mean, we provide very user-friendly APIs. Like our default APIs are not publisher track, subscriber track. They're like enable audio. More user-friendly, we provide UI kits and a lot of add-ons that help users get started really fast. So that's what our core USP is. And we have web, mobile, and desktop targets, all popular frameworks and languages. So like over the last 2 years, we've dealt with getUserMedia and had to handle the quirks of different browsers and their variants. And this is a talk about just navigating through it and what does it take to successfully have this is also just focused on web, so not talking about media acquisition on mobile, but yeah. So we're gonna talk about, like if you talk about the journey of the media, you start with the acquisition, probably then encoding happens and transmission, then on the remote end there's decoding and playback. So if I put the journey of media in this, like these 5 boxes, today we're gonna talk about acquisition, playback, a little bit of encoding, not too much, and the workshop is gonna be in a game format where we're gonna like introduce a game midway and we'll probably let you play around with getUserMedia. So yeah, this is the API that all web developers have to use to ask the browser for the audio video tracks. So like your browser has access to camera and microphone, but for you to get access to that in the JavaScript context, that's the web JavaScript API that the web provides. So navigator.mediadevices.getUserMedia. getUserMedia is a function and where you pass whether you want audio, video. There's tons of more configuration to it, but we're gonna start with just this. So you do this, it's a async call. When it resolves, you get a media stream out of it. And a media stream can hold multiple tracks, and tracks are the ones that contain the actual audio video data. So when you do this, when I do audio video true, I get a media stream with both audio and video track in it. And we will start with the workshop. We'll let you have a go at it. Tarush, you want to take over?
Hi. So yeah, I think everyone can just first navigate to the link, and you should see something like, yeah, you can do it.
I'll do that.
Yeah. Something like this. Is everyone able to open the link? Yeah. Okay. So.
And I hope you all have like good enough devices because
Yeah.
it's gonna take some processing.
Yeah. So once you hit play, you will see a playground like this. This is where we expect you to write the acquisition code. And what this function expects to return is one audio stream and one video stream. Now, internally, how it's going to work is, if I just run this first. Yeah, once this runs, we are actually emulating 100 different environments that we have noticed our users have. And each of these environments it's Windows, Macs, it's some mobile web browsers. We're trying to get a mix of every single type of failure we've seen and try to emulate what is possible, what types of errors are possible. So, yeah.
Internally, we have a library called Device Simulator that we use to run tests, simulate failure, run tests. It's like a reverse adapter.js, if you're aware of this, that not only emulates constraints, but other types of failures that browsers can have.
Yeah,
The code's not clear. Let's see what we can do about it.
I can just zoom in.
It's probably got to do with the theme.
It's okay. So I'm just going to type in what we just saw on the previous side, which is navigator.mediadevices.getUserMedia. And for now, we'll just start off with audio true and video true. Yeah. And once we have this, if I do this, so this is what the return format of the function is. Again, we made this like in the last 2 days, so I couldn't properly mention what the return type should be. But it looks something like this. And video. Yep.
We'll just walk around and make sure everybody gets it. But as I was explaining earlier, there's a stream and it contains both audio video tracks. So it has a method to like get an audio track and you're selecting the first one because there's just one. If you could just all write that and we'll walk around and internally, the way it works is it'll override the browser's getUserMedia and like have a fake getUserMedia where we have programmed all the failures and the constraint errors.
Yeah.
So
running this. Yep. So how the test itself works is it's a 6-second test. And if you see earlier, there were a few devices working, but it also emulates device failures on the go. So let's say a user connected a device, it worked on acquisition, but after 2 or 3 seconds, that device failed. It could be a Bluetooth device running out of battery, it could be a hardware failure, it could be any of these things. So with the very simple audio true, video true, we can actually see that 60% of the environments actually ran successfully. Like there was no over-engineering sort of required here, but 40% still managed to fail. And most of these failures we have noticed come from Windows devices which have like multiple of those real tech media drivers in, or mobile web browsers where they've maybe minimized the tab, or a bunch of failures. So has everyone reached this kind of screen?
oh yeah, we forgot to recommend to
Chromium.
Screw. It's web RDC. Yeah. No, just navigate to this URL comcon.dite.io.
And yep, this is the.
Yeah, you have to type this in.
Right. So what we've seen now is 40% of these device failures coming in. And the next part is going to be how do we fix the 40% that, and we'll take it one by one. So the way it has actually been built, we have 10% of the devices failed on the gum call itself.
Error handling.
So if I just head over to the results, and let's just pick this device. This will give you like kind of a debugger in here, where you see that there's no track states that you see right now. You just see that the getUserMedia itself failed. And if you head over to, so they're all in brackets actually. The first 10 are 1 failures, the next 10 are 1, next 10 are 1, next 10 are 1. So in the first 10, if we see the track's enabled, but the ready state has switched to ended. Now, we're going to dive deep into what this actually means so that we can solve this issue. So, yeah, this is basically the life of a web developer who is building WebRTC applications. You get a track, you share the track, and then you will find that the track doesn't work. Maybe it's going to be instant, maybe it's going to be later, but that's what ends up happening. And the core strategy for any web app that's trying to build anything on top of getUserMedia is you acquire a track, you verify if that track is okay to share. If it's not, you reacquire the track. at the core, I believe that's what every strategy tries to do. And we'll build more on these strategies as we go on. So, right. Now, any device can have multiple input devices and multiple output devices. In this workshop, we're going to be touching more on input devices and majorly audio ones. So if you see in this scenario, this is an environment that we have seen where you have the MacBook microphone and you have an iPhone continuity camera also plugged in. And you have, I think, just one virtual speaker here. So in this scenario, it's very difficult to understand which camera the user wants to use and which one to rely on, and maybe if the user switches their camera, and how does that decision affect the future meetings or future calls that this user is going to join. So basically the strategy that we take are end users are dumb. And I think this has worked the best for us so far. And to dive a little deeper into it, an end user doesn't know which device is best for them until they have actually gone ahead and selected it from the drop-down list. So what that means is their default device could be the MacBook microphone, but they could have, let's say, AirPods plugged in, or they could have a headset plugged in. Irrespective of that, the audio through video through that we just ran would give us the default microphone, which would be a bad end experience for the user. Right. Now, coming back to the game itself, on how we decide whether a track works or not. A track only has these 3 states which determine whether it's okay or not, according to MDN at least, where the first one is enabled. So this is what we control ourselves. This is used for muting and unmuting. And yes, there is a muted state, but for some reason, enabled is the one that you have to use, which controls us making the track muted or not. Secondly, you have a ready state. Now, ready state signifies whether this track is able to currently produce data or not. So, and it usually goes into ended states only mostly in hardware failures. And live is when it's working perfectly fine. Now, the last one, muted, is a little interesting because, again, according to MDN, it's supposed to flick the muted to true when there are 0 audio frames coming in. But we have noticed in our own examples where that state doesn't switch, even though it's muted. And we'll come to how to deal with that as well.
Every browser has a different implementation of muted. And even though it says it's not muted, there might actually not be any audio data coming in. Typically, you'll see this in microphones with hardware mute devices. So once you toggle that off, it should reflect muted as true. But more often, it does not.
So, right, if we were just to translate this to JavaScript, you make sure you have a track. You want to make sure that the ready state is live, and you want to make sure it's enabled and it's not muted. That should be like the entire thing that works, right? It's not. So, yeah. And so this is what we are using even in the game right now. If you've been trying to solve it, there are solutions that will come at incremental steps. But to talk a little more about strategies, yeah.
Yeah, so just going back a slide, and what you do is you acquire a stream, and then you verify it. After the verification, you have two choices. You can reacquire it, or if there are multiple inputs, you can try acquiring an alternate one. And it totally depends on how you want to do it. There's no recommended or good way. But in case there are multiple ones and you want to try it out, you can. What we do, and that's what I'm going to show, is the first pass, we filter out known bad devices. It's basically like a static list that we have compiled over the years. I'm not sure how many of you have dealt with iPhone continuity, but it is a pain. And to those of you who don't know what it is, in the iOS 16 update, Apple introduced a way for Safari browsers, and not just Safari, Mac, any browser on the Mac, to acquire webcam and microphone of an iPhone connected to the same user. For webcams, it's great. You get a high quality camera, like the MacBook cameras are not that great. But for audio, I don't see a use case where people use a microphone audio from their, And it's just not about the use case. What we have seen hundreds of times is it'll disconnect, it'll reconnect, it'll disconnect and reconnect. iPhone continuity on microphone is like definitely not a device that we would want to select on priority. Same for monitor devices. On Linux machines, there's like monitor audio drivers that basically have no data in it. And so we maintain a list of like known bad devices. And when our app first loads, when our SDK first loads, what we do is filter out all the devices, sort them according to, like deprioritize these devices. Again, you don't have to do that, but just you can do that to maybe ensure a better experience. And as we said earlier, dot muted might not reflect the muted state always. So what you could do is take this muting detection to like sort of user land if we're going into that kernel user analogy. So you don't leave it up to the browser to decide the muted state. For audio, you use the web audio API and actually run some tests on it. Are there samples in the audio? And for video, what you do is you take that video, you put it on the canvas, and then basically you can then run any sort of like simple algorithm to detect if it's all black frames or there's an actual image in that video. So with these, and again, you don't have to run them all the time, you just have to run them on the first acquisition. So once you acquire it, you can use this to like verify, just another step in verification that, hey, I have a track that contains audio or that contains video. So we've basically covered 4 different things. One is these properties of a track. Then we're also removing known bad devices. We're also checking the muting, again, on the user layer. That's one part of the acquisition game. The second is, of course, I think like a lot of you who have dealt with web are familiar with this. So in the earlier example, you saw an audio true, video true, but that's not how most people use it. People have specific constraints that they want. They don't want their video, they don't want to stream a 4K video. They would want to put a cap on it, put a cap on frame rate, determine what's the ideal frame rate, what's the max frame rate do you want. And so you get constraints. And the funny thing here is every browser supports a different variety of constraints. And you constantly have to deal with browsers changing what constraints are acceptable, even though there's like a spec for it and everything. So how many of you are aware of adapter.js? Yeah, so it's still a thing. It's been, I don't know what, 7, 8, 10 years. It should not be a thing in 23. And that's why you have to like test your builds and dev beta builds of browser. And what we have done recently is implement remote overrides. So on Safari 16.4, we saw, hey, you can't use frame rate ideal and max both at the same time. So, and especially for an SDK company and you're shipping out SDK, you can't, it's not a web app that you can remotely update. So having constraints override on having remote overrides on your constraint is a recommended thing. So that's about acquisition. Till now, we have acquired a device, made sure. Yeah, you have a question. We've made this, it's a very simple demo. We recommend you to use Chrome. Yeah.
I'm just curious why it doesn't work in Safari.
It's probably to do about how we are emulating the devices.
Oh, okay.
So, yeah.
So for emulating like audio devices, we use web audio, which is available everywhere. But for media, we are doing Canvas. And Canvas on Safari, like it's available, but like it doesn't have I think they recently introduced off-screen Canvas.
Yeah.
Before that, like it's not. I think we use off-screen Canvas to simulate a fake video out of a machine. So that's acquisition, but that's not all that. Like you have successfully acquired a stream, and multiple things can happen. So having a successful local audio also requires making sure that retention is there. And you want to take over?
Yeah. Right. So we just come back to the game in a minute. Now that you have acquired a track, we're going to deal with the retention and also how to correctly acquire the track itself. Now, if I just quickly come back here. Okay. Yeah. So if you take this example, if you see the getUserMedia itself failed, and there is a very easy way to deal with it, which is you just put a try catch on the getUserMedia itself, and you can just click on hint one, and it's going to give you something like this.
There's a bug in the hints.
Yeah,
So once you click any of the hints, you just have to change one character anywhere for it to run.
Yep.
Yeah.
So this is the same as we wrote before, where you have audio true, video true. All we've done is put a catch around it. Now, if you see, whatever true device that we were trying to get, whatever the browser thought that the default device was, actually failed in giving us a track. So if it's a not allowed error, that means it's a permission error. This is probably not recoverable instantly. This is a user action that would fix it. So you can just ignore this. None of the environments are going to give you this. And what we're going to do now is we're going to see what devices are available to us. So we've gotten all the audio devices through an API which is called enumerate devices. You now have audio devices and video devices, and this is where I would say the core logic of any web app using WebRTC is going to come in, where you're trying to figure out which device is the correct one for this user. And as we progress through the hints, you'll see what strategy we use. So acquisition now, this strategy, I would suggest, I think
I would recommend all you to click on hint one, get this boilerplate code, and then write from here.
Yeah. So what we're trying to do is figure out which device to use at this point. Yeah.
Clearly the default one failed, and that's why you are on.
Right. And the point where, so let's say we have a very dumb strategy where we're going to go through every single device and we're going to see whether this device works or not. If it works, just return that track. Sounds simple enough. And how you end up doing that is, again,
Just go over and maybe talk about it.
Yeah. So now that we're building our strategy, again, audio devices and video devices, something that you guys should be seeing on your screen right now. And let's just try to get a track over here. So maybe just take like 2-3 minutes and see what kind of strategy you can come up with to build this track.
Oh, it's already here. Yeah, it's already there. The first.
I'll just.
Yeah. The line 5-6 is what we were trying earlier. So there's a function on top is stream valid, which basically checks the sanity of check. If it's not muted, if the ready state is live.
You can just hit hint one. That'll give you the code. Yeah. That's it. Yeah, this should work now.
And again, line 4 to 12, you're trying to acquire the default device. It did not work. 14, 15, you have the list of other devices. We did not walk them through the device ID.
Yeah,
So getUserMedia allows you to specify the device ID you want to capture. You want to write the boilerplate code for that.
So the strategy that we are actually going to implement in this workshop is going to be the one that I described earlier, which is going over every audio device, finding the one that works, returning it, going over every video device, finding the one that works, and just returning it. Now, what we use even at Dite is similar to this, but it has some sort of sorting and priority to make sure that we get the first working device as soon as possible. And we usually go into a flow like this, where we are actually iterating over devices only in about 4 to 5% of all environments. But this is what we've ended up with. Now, what we do is we have our devices. acquire a track from that device. So this is how that constraint looks, which is getUserMedia device ID is the device ID that we received from enumerate devices. Same, the get audio tracks that we used earlier. And we just, if that stream is valid, we return the track. And the function is stream valid itself is the same thing that we wrote earlier, which is enabled, not muted, and ready state is live. So if you actually just hit hint 2 on your laptops, you would have this particular boilerplate code ready. And if we actually run it, you will see one sec. Hint 2 and just make sure to like add a line. So, yeah. Yep.
So this is, let me see. Oh, I'm trying to work out.
So if we take a look here, you will see that the middle of these devices, these were the ones where the gum actually failed, now starts working.
So
So
this
you-
error is not recoverable.
Yeah, so you have 10% of the devices that are now working. And what you
Yeah.
can now do is see what other devices are failing and why they're failing. So if we head over to the last 10, you'll see that the ready state's fine, the enable is fine, but these are muted. And in fact, if I run it again, what you'll see is they are not failing on acquisition. Like right now, these are fine and these are fine. But if you let it run for 3-4 seconds, you'll see that they fail afterwards. This is where the entire retention problem statement comes in, where acquisition time, tracks are okay. But after you acquired them, something failed for these tracks to stop working. So that's what I'm going to talk about real quick.
Can I ask a question?
Yeah.
With the matrix, what does that represent? Does it represent individual devices?
Oh, I think you missed that part. So what we've done is these are 100 different environments. Each environment represents a browser.
It's a different OS, different browser, different set of devices it has.
Cool. So coming to retention, yep. Yeah, just a quick statement about how the track states can change. This is a basic kind of life cycle. The enable state switches according to us. There is no user action or no browser action that's ever going to change the enable state.
Typically, to mute and unmute, like you go to any web video conferencing app, and you click mute and mute, you're changing the track enabled state internally. And that's
Yeah.
how typically the muting is implemented. There are of course other ways to implement it.
Yeah.
So why would you, like you've got a, so I understand this, you've got a weaker criteria for if the first getUserMedia returns 2 tracks, then you accept it without testing whether they're valid or not.
Yeah, that's
Whereas the others you have stricter criteria for. If it's failed once, you have a stricter criteria. Is
So-
that the result of experiment that's a good way to go? Or?
No, that's not intended. Like
we were waiting for someone to
Oh, okay.
pick up on that. So yeah. So hint 2 is not the complete solution. Hint 2 is just seeing whether the getUserMedia failed. Could be permission errors, could be device errors, and that's what we're trying to recover from. We still haven't checked whether that track itself was valid in hint 2.
no, we
or
did
not.
check it on the other alternate device.
Alternative ones, but not the first one. Yeah. So again, coming back to the lifecycle, enabled, controlled by us. Ready state only moves to ended. Once a track has reached ready state ended, there is no chance of it coming back to live. You can basically consider this as dead. And muted, there are ways where it goes to false and true. For example, a hardware switch that you're flicking on a hardware device for audio. Yeah. So for noticing these events, for us to know whether a track is still working after retaining it, what we do is we add listeners. This is what the browser gives to us. We have ended and we have muted. And in ended, again, this is irrecoverable. So you just stop this track, get done with this device, and try to fetch another device. And on muted states, there are multiple strategies to deal with this. One is either wait for it to unmute if you know that this device is a good one, again, from maintaining a list of the bad devices. Or you, again, just employ the same strategy as ended, where you just stop this track and get a new one.
Typically, like there's no best solution here. Any solution here also involves user feedback that, hey, there's no audio. Do you want to switch to an alternate device? Something like that. Yeah.
Um, yeah. Also, there's just two things I'll quickly touch on. Retention, another problem comes in what happens when a new device is connected. So if someone is in your meeting and they connect a new Bluetooth device, should you switch to it or should you not switch to it? That is, again, a complete UX kind of issue where do you want to switch devices without informing the user or do you want user input here? I would say this is something we're still experimenting with to figure out the best. But what we've seen is mostly automatic switching is what the users want if they're connecting a new device.
Yeah, if in the middle of a meeting you're connecting a new device,
Probably
you'd want to switch to that.
Yeah. And another thing is on mobile browsers, if you basically close your web browser and you open it again,
Not close it, like just minimize it
Yeah.
or like screen lock it and then come back to it.
in scenarios like that, we've noticed as soon as you background your app, the tracks stop or the tracks switch to muted or tracks go to ended. Mostly it's the ended part. And this actually we noticed the first time on iPhones on low battery power on Safari. If they're connected to the meeting and you minimize Safari, that track's going to end. And you're remotely sharing this track. It has ended on your user without him or them explicitly saying video off. And how do you communicate that to the rest of the meeting?
So yeah, whenever the user foregrounds the tab or the app, you run a full test again. You check all the states of the app, you run maybe a silent detection, muting detection.
I'm just going to skip this part. I think we're running out of time a little.
Yeah.
Yeah. Very quickly, the permissions is also something I'll just quickly touch upon. If a user denies permission to your particular tab, you know that because your getUserMedia failed with the not allowed error. That's when you need to show a prompt to your user or a pop-up, which in most cases is just an arrow pointing to that square on the top left of a browser, saying, hey, you need to allow access here. But there are also cases where they allow access, you now have access, and what a user ends up doing is removing permission during runtime. This is happening in scenarios where people notice that the setup screen or the setup state has their video track. They realize, oh, I don't want to give permission, and that's when they change it. Now, dealing with that is also a problem because you have a track, but that track is suddenly not valid anymore because the permissions are gone. In some browsers, that gives us black frames or zero audio samples. In some browsers, that just moves to ended state. And it's just something that we have to look out for. And we actually have a web API, the permissions API, that emits events every time there's a permission update. So we do deal with that and then accordingly give users the feedback that, hey, I think your permissions changed, you need to switch that back. Yeah, yes.
Sometimes some other application has control over the camera or the audio device.
Right.
The user cannot select that device. So is there a mechanism for us to notify the user at that point that we need to close the other application? Is there a way to find that?
So usually there's very specific errors that come up when the particular device is already in use. I think it's called the not readable error or something similar. So the way we do it is we just match error names because they're standardized across browsers. So if you're receiving a not readable, it means that it's in use. And you probably try to acquire a different track instead of informing the user that.
If there's an alternate device available, our default strategy would be to choose that alternate device. But if there are none available, you give the UI feedback to the user that, hey, we can't access your device. Please close other applications.
So in a nutshell, So in a nutshell, this is what we believe the optimal strategy is at this point. Again, this can change in the next 3 months, 2 months. We usually
Sort of simplified view, doesn't look simplified, but
yeah. So starting off with the enumerated devices, I think this is on your hint too. If you click on it, you have all the devices possible. So you actually do not start with audio true, video true ever, because usually that ends up giving you a bad result. Enumerated devices, you now have access to all devices, all labels. Let's say this user actually has joined your meeting in the past, and you have information that there are some devices that have worked previously. You could maybe store these devices in a local storage as good devices, or store bad devices as bad devices, and you actually sort the result from here onto what you think would be the best, onto what you think would be the worst. because you need to make this as quick as possible, and the user shouldn't notice a delay when you're iterating over every single device to get a track. So sort the list, get user media. If that particular track failed or is not valid, get user media on the next device in the list. Same, iteratively until you get a success. Success, yep, you just verify, attach your listeners, which we'll come to in a bit, and share the track. But there's also cases where no device failed, and you have a complete failure here. This is where you need to inform the user that none of their devices are working, because users, as stated previously, and users are dumb, so they will keep clicking on the mic on, video on, and it would not work. So usually a permission prompt here, like a sort of icon just to show them that you've reached complete failure here, is what we end up doing. And the last route, there can be permission updates even after success, which is what we listen to using the API that we mentioned earlier. And I think we can just quickly finish the game as well. So we've reached this state where we have this 10% working because we did the try catch on the get user media. And what we'll do now is you can just hit hint 3, and this should be the final result of what should work. So to quickly go over it, this is what we started off with, audio true, video true. We're sticking with it for now to get the default devices. We are checking whether the streams are valid or not. If they're valid, we are attaching listeners to these streams to check the ended and muted, which you can see over here, ended, muted. And if they are, we just reacquire the track. If not allowed, again, permission error needs to go to UI feedback, completely gone. And the strategy, this one we saw in hint 2 itself, where you iterate over each device, you see which one is working, which one is valid, and you're just setting that to true. And what this will do is now, if I hit play, you will see that every single device, even after failing after 2 seconds or 3 seconds, was reacquired and does end up working now. So yeah, hint 3 is what I would say the fastest strategy is, like if you just need to go to market tomorrow, that's what you should use, and iteratively work on it, on top of it. And yeah. I'll just walk around as well. You can start on the playback.
Yeah, sorry.
So getUserMedia depends on the OS's return on the list, right? And
Yes.
in Windows, you have sometimes the communication device, and the default device also gets selected.
Yep.
Now, to one-on-one, how do you verify? And the labels are not often explicit.
Sure.
Right? So how do you verify that the communication device which is on one machine is a bad list and the other time is also the same? Like, how do you keep track of it?
No, so the known bad device thing, it's just that static list is just to make this process faster. Even if you don't have that, you could iterate through all of them and check if it's working. So that's just to make it faster.
It's like a very temporary thing. You're not pushing back the server or something like that. You're not maintaining it.
Yeah, so usually the way we end up updating that list is like we get a complaint and we see what's happening, and we're seeing that, hey, this is the monitor device. And once we see like a lot of failures, we try to avoid it. But you don't need to have that. It's just to make it quicker. Like you just have a sort before, because acquiring a media, running test on it is like a 400 millisecond, 500 millisecond process. If you have 4 or 5 devices, 2-3 seconds, you just want to minimize that time quickly.
I think there was a mistake on an earlier slide that you can't, if you enumerate devices on Safari before you've done a get user media, then you don't get all the devices. And you certainly don't get all the labels.
You don't get all the labels, but
Labels, yeah.
you get the devices.
No, I thought you only get the default device.
Oh, all right.
And that was actually a question I wanted to
So
ask.
you need to call get user media, and if you want to throw the results away, that's fine. And having called it, now you can.
Yeah, that's why in the example, if you see, we did a true. Yeah.
Right. Yeah.
Yeah, I do remember a bug. WebKit, not WebKit, Chrome bug.
That was my question actually. Do we have a strategy for that to happen? Like when it's implemented in every browser, and enumerate devices is actually useless unless you call it getUserMedia?
That was a simplification, but yeah, we Like you need permissions, and if there are no permissions, you'll first try to acquire a permission and then run those things. Yeah. Just going to the last part of this thing, playback. We're not going to run any demos on this, but you can't explicitly set output device in most browsers except Chromium devices. So I can't select. I'll just have to depend on the system to route my audio. True for all mobile devices and like even on desktops. Firefox, it says nightly, but it's enabled behind a flag. It's not. It has been nightly, like behind this flag for like 20 releases right now. So you can't do that. You just have to have a good faith, like ask the user through some user interface hints to select the right audio device. And autoplay error. You can't see this meme. I didn't make this meme. Somebody did. But since last few years, autoplay has always caused problems when you want to play audio video without user interacting it. So again, you get a play failure. You have to implement some sort of like an action so the user clicks on it. There's no getting around to it. So even if you ignore autoplay, even if you ignore other things, even simple audio playback has some quirks around it. I'll just talk about like this one quirk where a participant has joined the meeting and you have a new audio track. It's a remote audio track. What you can do is create a new like audio element in the DOM and assign that track to it. Typically this works. Like you got a new track, you create a new audio element and you play that. But Safari will not let you create new audio tags when in background. So every browser has its own quirks. Now you can use the Web Audio API to play that audio, but Web Audio API does not work with noise cancellation. Like WebRTC noise cancellation will be deactivated if you use Web Audio to play that remote track. There's a issue ID. It's been there forever. What we have sort of come up with, I'm sure there'll be other approaches, is we have one audio element throughout the page, and that contains just one media stream. And what you can do is you can add multiple tracks to that media stream. So even like a new participant a new remote track, you add it to the existing media stream. Some quirks again, like you have to call play on Safari, do SRC object on Chrome, just weird implementations all around. But yeah. Couple of different things, not really, I would say it's bonus, is we have done a few checks on audio video on like at the track layer, like track properties, but you could also use getStats API. So we have done the silence detection after acquiring, but if you want to keep doing that, what you can use is like the total audio energy, total samples duration. So like at runtime have these assertions that, hey, there is audio flowing through the peer connection. Second one is actually really cool. So not sure like how many of you are aware, but typically screen shares have these problem, whether do you focus on the quality or do you focus on the frame rate? And you don't know if I'm screen sharing a tab which has a YouTube video playing or I'm screen sharing a slide and which has static content. So when you're acquiring that media, you specify, hey, this is my constraints, but you don't get to specify, you don't know the type of content the user is going to play. So what we can do is use QPSum. It's a metric in video encoders. Typically, like when you combine this with the target bandwidth on the bandwidth, you can detect if the video content is static or dynamic, and then use like apply constraints to change your constraints on if one of them want a higher FPS or a lower FPS. So there are a couple more other like runtime assertions that you could do with getStats to make sure that all the audio is flowing through correctly or all the video is flowing through correctly. There's also one more property that touches the encoding process, the content hint. WebRTC is not unidirectional. You're sending audio video, but you're also receiving feedback for it. And sometimes, and those feedback affect how audio video is encoded. Okay, so if you are, and what you can do is you can set a content hint on the track to like give hint to the encoder that, hey, there's I want detail in this, there's text. These are like, there's also degradation preference which does this, but this basically is balanced, like maintain FPS, maintain quality, or keep it balanced. So like these three properties let you just hint the encoder that, hey, how many of you are aware of this? So every Chromium device ships with a hidden Google extension, and which gives Google some few APIs that is, Google Meet a few APIs that's not available to every other web conferencing app. If you have attended a Google Meet and tried to share a tab, what you would see is you'd get the options there itself, whether you want to select a tab or a window. That API is not available to anyone. And the way it works is there's a hidden extension. Google Meet communicates to that hidden extension. And then there's a Chromium source link. It's there in all Chrome browsers. Yeah. That's all. That's all we had. There were some quirks around the demo, but hopefully we'll be able to polish it and put it out somewhere for all of you to try. That's all. Tarush wants to say something.
Yeah, we are probably going to open source whatever we built with the device emulator and the hundreds of environments that we showed you. And yeah, if you want to try the game out in your free time, I think we'll keep the link up. It's comcon.dite.io. Yeah, thank you.
Any questions?
Are you going to open source the list of devices you have problems with?
It's a small list, and yeah, sure, but I don't think it'll be helpful to anyone.
After the beer, maybe.
We are preparing our whole list, so I just want to kind of
Okay, sure.
hear everything.
All right. Yeah, typically we have seen virtual devices give a lot of issues. Anything that has the name virtual in it, or there you don't really have an option of switching to something else. And there's like, I'm not sure if it's something unique to VWork, but VWork India has this horrendous app that they make us install to like screen share in a conference room, and that gives you a virtual audio video device that never works. Yeah. So few devices like that.
Yeah,
Well, thank you.
thanks.
So thank you, Palash and Tarush from Dite. And did you enjoy the workshop?